Alrighty, here's the review packet. See if we can do this uncut. So much fun. I'm ready. Alright, find the component form with an initial point 5, 7 and terminal point -1, 4. So we're going to use the head minus tail method, which means that wherever the terminal point is, which would be the arrowhead part of it, we do that minus the tail, which is the part that doesn't have the arrowhead on it. So just -1 minus 5 and 4 minus 7. So just -6, -3. So that's what the vector is. That's between those 2 points. All right, 2. Given vectors A and B, find -4A and A plus 3B. All right, so for 2A, first thing we can do is just rewrite what these vectors are without the i's and the j's. So this is really 4, -3, and B is actually 1, -2. So if I'm just doing -4A, well, I'm just going to multiply each part by -4. So I get -16, and then I get +12, and I just have to rewrite my answer in the same form. So since the original ones were in i's and j's, I got to write my answer with i's and j's. So it's -16i plus 12j. And to do the a plus 3b part, same thing. So I'll just have a, which is 4, -3, and I'll add that with 3 times b, so that's 3 and -6. So 7 and -9, I believe. And then, again, I just got to rewrite it. 7i minus 9j. 2b, same exact idea. So -4a, in this case, right, we have a new set of a's and b's. I'm not even going to bother rewriting them. I'm just hoping that you'll be able to follow along. So I just get 4 times the x and 4 times the y. For a plus 3b, that is going to be -2, 3 plus a -6, 3. And then I'll just add them together, so -8, 6. And there's 2a and b. Let's change the color up, why don't we? And scroll up a little bit on my answer key. Alright, so 3a is a calculator question. So it says find the magnitude and the direction angle of w, which is -6, -1. So to find the magnitude, we just do a squared plus b squared in the square root. And I'm pretty positive that that's the square root of 37. Now, to find the direction angle, my answer key is going to do it slightly differently than the way that I've been teaching you here. I'm just going to do tan inverse, okay, of y over x, so of -1 over -6, and that is going to give me, when I type it in the calculator, -9 point, not -9, it's going to give me +9. Sorry. And from here, what I need to do is pay attention to what quadrant this vector's in. So I have -x and -y, so that's going to be in quadrant 3. So I know that this is the reference angle, but the actual direction angle for something in quadrant 3 is going to be 180 plus the reference angle. So I'm just going to do 180 plus this 9 point whatever to get the actual direction angle. So it's going to be 189.46. Whew. You know, it's really difficult to like talk and write at the same time. 3b is a non-calc question. So I'm given vector w, not w, v, 2, -2, rad 3. So if I want to find the magnitude of this, again, I'm just going to a squared plus b squared in the square root. So it's going to be 4 plus 4 times 3. Okay, so that's 12. and this is going to be square root of 16, so it's going to be 4. Now, when I go to do my tan inverse of y over x, I get negative 2 rad 3 over 2. So this is just a negative square root of 3, and I know that angle already. So if tangent were to equal, let's just try that again. If tangent were to be negative, we know it's tan inverse, so it can't actually exist over here. And if it's negative, we know it's going to be down here. This is going to be the square root of 3. That would be 1, and that would be 2. So I know that this is going to be a 60 right there. Right? So my reference angle is 60 degrees. More importantly, I guess it would be negative 60 in this case, but reference angles are always positive. So we're going to do that. Now, if I'm looking at this actual vector right here, it's positive x, negative y. That's going to be in the fourth quadrant. So its direction angle is going to come all the way around. So it would be 360 minus the reference angle. Or I could use negative angles if I wanted to. It doesn't really matter. So I'm going to do 300 or negative 60. I just tend to stick with positive angles personally. Woo! This is so much fun. For A and B, again, there's a non-calc and a calc part of this. For A is going to be a calculator question, so I'm given a magnitude 32, direction angle of 127. So I'm just going to use that formula, which is that it's magnitude cosine theta, magnitude sine theta. And I'm hoping that this still, this feels okay to you, because this is the x value and that's the y value. Cosine's x and sine is y. So I'm hoping that this isn't the worst thing in the world that you've had to learn here. Do you know why that song stuck in my head? I don't know either. So let's see, 19.26. So I just used the calculator to figure out what these numbers were, and 2556. And I always like to just do a quick double check here. So if a direction angle is going to be 127, I'd end up in quadrant 2 with a negative x and a positive y. So this worked out perfectly. For B, where I'm given the magnitude is 5 and the direction angle is 330, I have two ways of doing this. I can just plug it right into the formula, so I'll get 5 cosine 330, 5 sine 330. And I just have to figure out what is cosine of 330, so its reference angle is 30. So this is going to be square root of 3 over 2 times 5. This is going to be 5 times negative 1/2. It's negative because we're in quadrant 4 and sine is negative. So I get my final answer is just going to be 5 rad 3 over 2 comma negative 5/2. We could also draw this one if we really wanted to, where it is. So here would be our little reference angle of 30. I have a magnitude of 5, so I can just use the pattern for a 30, 60, 90, which is that this side is half as big as the hypotenuse, and then this side is, that side times the square root of 3. So that's just following that normal pattern that we're used to seeing with 30, 60, 90s. So either way, I would have gotten the two different components that we got over here. It all just depends on which way you like to do it. So we got dot product next. Just remind you, it's basically the x values multiplied by each other. The formula that I used was u1 v1 plus u2 v2. You could also think of that as x1 x2 plus y2 y1 y2. So I'm basically just taking the x values and multiplying, and the y values multiplying and adding. So for 5a, with negative 1, 2, and 0, 5, you just do negative 1 times 0 plus 2 times 5. So that's 0, that's 10. So the dot product equals 10. 5b, I'm going to do the same thing. I'm just going to pull it out of the ij form, so I really have 3, negative 3, and I'm doing that dot product of 2, 1. So I'm going to have 3 times 2. I guess I'm writing it long-winded apparently. So that's going to be 6 plus negative 3, which is 3. And there's your dot product. Whew. Now scroll that answer key up. Right, angle in between. This is one of those really, really important formulas. So I'm actually just going to write some of the formulas up here just so that I can refer back to them if I need to. Really don't like writing in this corner because you can see my head. I end up leaning awkwardly away from it. All right. So it says that this could be calc or non-calc, but both examples are actually going to be calculator based. And I'll get to the point where I could kind of tell you like what would happen, but basically if we calculated this side and it ended up equaling like a 1/2 or a square root of 3 over 2 or a square root of 2 over 2 or 1 or a negative 1 or a 0, then we can find theta because we know what those cosine values are. There's either a 30, a 60, 45, you know, a 0, 180, or a 90. So we could figure it out without a calculator if we needed to. So this first one, I'm actually going to show you 2 ways. The way that the answer key does it, and then I'll show you the way that you could also do it. If you happen to recognize, like I did right away, that this is a special pair and that this is a special pair. So this is a 45 and this is a 30, I believe. So I could show you another way of doing that kind of later. Just do it the original way first. So first thing I'm going to do is just find the magnitude of this. So 3 square root of 3 squared plus 1 squared, and then the square root of that. So that's going to equal 2. I guess I should actually use the right notation here. And let's see, this guy is going to be square root of 18, which is 9, not 9, 3 rad 2. And then I'm just going to plug it in to the formula. So I have cosine theta equals the dot product. So that's going to be 3 square roots of 3 plus 1 times 3 over their 2 magnitudes. So 2 times 3 rad 2, which is going to be 6 rad 2. So now this is what I was talking about. If this had equaled any of these numbers over here, then we would be able to find theta without a calculator. As it is, I'm going to do cosine inverse of all of that junk, and I'm going to get 15 degrees. So the angle in between those two is going to be 15, which makes sense because I guessed that that one was 30 and that this one is 45. So it should make sense to you that that happened. Let me show you how I guessed that. So for this first one up here, I just kind of graphed it super quick in my head. I recognized the 1 and the square root of 3 as being special numbers, and that was going to be 30. So its direction angle is 30. And this one up here, it's 3 and 3, so that's a 45, 45. Also get its magnitude really easily, so then I can literally just do 45 minus 30. And I know the angle in between is going to be 15. So that would only work if it happened to give you special right triangles in the original ones, which does not happen with part B. But it's the same idea. So 6b, we have 7i plus 8j and negative 2i plus 10j. So I'm just going to use the formula. I'm going to do dot product. So I'll get negative 14 plus 80 all over the magnitude of this, which is going to be whatever 49 plus 64 is. I'm just cheating and looking at my answer key. Same thing over here. I get 4 plus 100, so that's going to be 104. And I will just type all of that carefully into my calculator. If I was doing this in the calculator all at once, you want to make sure that you put parentheses around that bottom part and also around the top part, so that you make sure that you're actually adding the top part before you start dividing. And when you do this, you get 52.5 degrees. So that's the angle in between. Woo! This is fun. 7. Magnitude of some vector is going to be 8 in the same direction as u equals that. So we have magnitude of vector v is equal to 8, and v is in the direction of u, which is 3, 9. So the way that we capture the direction is with the unit vector. So to find the unit vector, I just find the current length of u. So that's going to be 9 squared plus 3 squared, which I'm pretty sure is just 90, the square root of 90, which I can simplify if I really wanted to. I could pull the 9 out, I'd get 3 rad 10. It's not super necessary, to be honest with you. So to actually find the unit vector now, I just divide each part by that. So the unit vector of vector u is just going to be 3 divided by 3 rad 10 and 9 divided by 3 rad 10. So that's the reason why I rationalize, is I can simplify now, so I can get 1 over the square root of 10, and this is 3 over the square root of 10. And that's the unit vector. So what that does is it captures the direction, but with a vector that has a length of 1. So if I wanted to have a length of 8, I just multiply it by 8. So I just do 8 times this vector. So I get 8 over the square root of 10 and 24 over the square root of 10. Boom. Done. Math. Oh my god, 8. There's like 8 million of these things. Ooh, fun. All right. So 8 is asking whether or not things are parallel, orthogonal, or neither. So if cosine theta were to equal plus or minus 1, that means the angle is either 0 or 180. And for us, we consider vectors to be parallel, whether they are going in the exact same direction or whether they are going in the exact opposite direction. Versus if it equaled 0, then they're that fancy word orthogonal, which basically means that they are perpendicular to each other. So that's what this is asking me to show, whether or not the angle in between is 0, 180, or 90. And that's it. And since we're teaching this kind of virtually here, right, and I'm not forcing you to do it the real way is to just always use this. So I'll kind of show you that, and then I'll show you the shortcut for some of them. Maybe I'll do the first 2 for realsies, and then do the second 2 with the shortcut. Does that sound like a plan? I'm talking to myself. Alright, here's u and v. I'm just going to find their magnitude first. So 5 squared plus 3 squared is 34. So that's going to be the square root of 34. And this is, when you know, the same exact thing. Off to a good start here. So I'm going to do the angle in between formula. So I got dot product. So it's going to be negative 5 times 3. So negative 5 times 3 plus 3 times 5 over their magnitudes, but I actually don't really need to do anything else because this is going to be negative 15 plus 15. So I'm going to have 0 over anything I want. And whenever cosine theta equals 0, we know that they're orthogonal. And that is because we get that theta is going to equal 90 degrees. And that is because if cosine equals 0, we know that the x value has to be 0. And that happens at 90. So we get that. So that was 8a. Let's just super quickly do 8b. U is square root of 2, square root of 2. The vector brackets around it that I keep forgetting to write for some reason. This is 3. And I can actually already see that these are going to be parallel. X and Y are equal, so the angle is going to be 45 and 45. And so they're going to be parallel with the angle in between being 0. But that's okay, we'll do the workout. This is going to be 2 plus 2 is 4, and the square root of that is going to be 2. And this is going to be 3 rad 2, so it's 9 plus 9 is 18, square root of that. So cosine theta is going to equal their dot products, so that's 3 rad 2 plus 3 rad 2 all over 2 times 3 rad 2. So that's 6 rad 2 over 6 rad 2, that's 1. And cosine theta equals 1 when theta equals 0. So that means that these guys are parallel. And I forgot that this guy is orthogonal. So let's do it the real way. For the next two, I'll use the shortcut way. And the shortcut way is basically saying, hey, vectors are kind of just making lines, in a sense. I mean, they're rays officially, but they make lines, and lines have slopes, and slopes can tell us whether things are parallel or perpendicular, aka orthogonal. So for this one, I'm just going to find the slope of each vector, because that's going to make my life a little bit easier. So the slope of this guy, so I'll call that mu. The slope of u is going to be the y over the x, right? Because slope is y over x. And mv is going to be y over x. Now, these guys are not parallel because the slopes are not the same, and they're not opposite reciprocal, so they are not orthogonal. So that means that these are neither parallel nor orthogonal. 8d, same exact idea. I have u equals the square root of 3, comma 1, and v equals negative 3 rad 3. So I'm just going to find the slope of this is 1 over the square root of 3. I'll leave it unrationalized for right this second. I might have to rationalize it though. I'm going to have to. So I get this. If I simplify that, it's that. And actually, I don't need to rationalize because they are opposite reciprocal. So these guys are orthogonal. I have no idea how to spell that. No idea if I spelled it right. I don't think there's an extra R there. Oh, because there is an R out there. Oh boy. Gosh, I kind of hope no one watches this. Ooh. Throwing stuff over here. 9. We have w is 4I minus 9j. We want to find vectors so that they're parallel. All right, this is easy actually to do. So I'm going to start off by just figuring out what is the slope of this vector. So that'd be negative 9 over 4. So as long as I maintain this exact slope, then I'm going to have something that's parallel. So literally all I need to do is just multiply this vector by any number in the world other than 0. So n cannot equal 0, and we'll also let n not equal 1, so it's not the exact same vector. So as long as that happens, these are going to be parallel with each other. If I want it to be orthogonal, aka perpendicular, then I need an opposite reciprocal slope. So I just need the slope here to be positive 4 over 9. That's what I need the slope to be. So I can just write a vector that's going to make that happen. So we have to remember that that's y and that's x. So I could just do 9i plus 4j. That's going to work. I could do basically any multiple of this now. So I can do n times ni plus 4j, where n is basically any real number is going to work here. Again, we'll kind of exclude 0. Just we don't want to count the 0 vector here. Woo. This is fun. I think we only have another page to go here. I am exhausted. All right. Let's see here. I feel like we're going to need to be precise here and use some of these fun new markers that I got. Brave to the store to buy them just for you. Got someone flying an airplane, compass heading of 160. So I'm going to do it this way. So we'll have plane, wind, and then the result, which is often referred to as the ground speed and ground direction. This is the air speed, air direction, things like that. I actually don't know if these markers are going to work too well for you. They're kind of thin, but we know that if we add the plane and the wind together, that gives us the ground. So compass heading, aka bearing, of 160. So I'm going to start up here and I'm going to come down here. And if it's a bearing of 160, that means that there's 20 left over before I would have hit 180. Okay, so if I'm coming all the way around, then this is actually going to be 270 plus 20. This is 290. So this is its actual direction angle. I'm hoping you can actually see that. So I personally don't ever write the bearing angle down. I'm always going to write the direction angle if I'm writing one down. And they told us that the plane is going 325. Wind is blowing at a bearing of 45, so that's going to be right here, 45. Again, I'm not writing the bearing, I'm writing the direction angle, and it's at 30. And I want to find the component form of the ground. So all I'm going to do is just first write the plane and the wind vectors out. So this is going to be 325 cosine 290, 325 sine 290. The wind is going to be 30 cosine 45 and 30 sine 45. And type it in the calculator to figure out what the result is. Okay, so I literally just do 325 cosine 290, close parentheses, plus 30 cosine 45. I'm going to get 132.37, and then same exact thing over here, and I get negative 284.19. Which I'm just going to make a little note to myself is in quadrant 4, and that kind of makes sense to me because this is a really strong wind, or a really strong plane vector right here, and the wind, while it's pushing that way, it's not going to be strong enough to actually push this so far up that it's going to be in quadrant 1. So it makes sense to me that the plane would be somewhere down here. So part 2 asks us to find the speed. So what I would have done is stored these as a and b in the calculator, and that way I could just literally do a squared plus b squared and the square root of that to get the speed. So the speed of this is the magnitude of this resulting vector. I forgot the L there. So I would just straight in the calculator, a squared plus b squared, square root, just make sure that that becomes positive when we square it. If you're using stored values, it just does it automatically, so don't need to worry about it. Okay, so that gives me how fast it's going. Now we want to know the direction of the plane. So what that's actually asking for is the bearing. So that's what I need to figure out first. That's what I need to figure out. I'm going to find the reference angle first. So again, my answer key is going to be different, but for us, we'll just do tan inverse of that y value over the a value. Again, that's good why it's stored for us, so that I don't have to actually think about this. And what this is going to give me is the reference angle, which I got to be a negative 65.02. Makes sense, it would be negative, we're in quadrant 4. And that's what this value is right here. So if I want the bearing, which comes from here, I just have to do 90 and then add that reference angle, but the absolute value of it. I don't want it to be negative when I'm adding it. So bearing, 90 plus positive 65.02, which is going to be 155.02. So that's the direction the plane needs, is actually going to be flying, and it's actually going to be traveling 313. So the wind has slowed it down. That was so much fun. Is this the last one? Good, because I'm dying here. Whew. I'm sitting on the floor writing this stuff. Not comfortable. All right, someone's flying a plane. They want to be flying south. Okay, so let's get our setup here. So this is the result, which in this case is what we want. Okay, here's the plane, and here's the wind. Let me just add those together, and that gives us what we're looking for here. So we want to fly south. That's the way we want to go. We know that there is a strong headwind blowing at a bearing of 190.55, so 190 is going to be here. It's going to be 10 past the 180 mark, 55. So I'm just going to write this out right now. Wind, we have 55 cosine. This is going to be from here. The direction angle would be 90, 180, 270 minus 10. So that's going to be 260. And 55 sine 260. Let's see. Now it tells us that the plane can go 400 with no wind whatsoever. So what we have to think about here is, this is the way we want to fly, okay? The wind is pushing us this way. So we need to kind of aim ourselves this way a little bit so that when the wind hits us, it pushes us to be going flat. So I know that the plane is going somewhere this way. Don't really know what, but I do know it's going 400. So I don't know what that angle is. So when I write the plane, I'm going to write 400 cosine theta because I don't know it, and 400 sine theta. And we know that if we add those together, they give us the result, or what we want in this case. So when I'm looking at this, the x value has to be 0 because if I'm going straight down, the x value is going to be 0, and I don't know what the y value is. So I'm going to let that be y. Now you could make that be negative y if you wanted to, because you know it's going down. I'm just going to let y just be positive for now, and when I find what y is, it will just end up being negative. So I basically don't need to think about it. And from here, what color haven't I used yet? I haven't used a lot of black, I guess. So I guess, ooh, green. Ooh, almost missed you, green. We want to find the compass heading, aka the bearing. So it's not that. What we want to find right now is this. But to do that, we first need to maybe figure out what theta is. Okay, so I know that the x's added together will equal 0, the y's added together equal y. So this equation has two unknowns, theta and y. This one only has one, theta. So I'm going to start off by focusing on that. So I get this little equation, 400 cosine theta plus 55 cosine 260, 60 equals 0. And I'm just going to subtract this to the other side, divide by 400, cosine inverse. I'm going to get that theta as a reference angle here is 88.63 degrees. Okay, so from this I can find two things. I can find the bearing, which is what I actually want to find. So the bearing is just going to be 90 plus that reference angle, right? Because I'm going to go from here, 90 plus a reference angle. And I'm running out of space here. The direction angle, okay, so theta as a direction angle, what I actually have labeled as purple, it's going to be 360 minus that reference angle. So they didn't actually ask for this in part A, but this is important for us to know what it is in part B, actually. So I'm going to write that one down, and then I guess I should write down what the actual answer is for the bearing. So this is the answer to part A, is the bearing is 178.63 degrees. Now for part B, I'm going to come up here into the corner I don't like writing in, so you can see my head. And let's figure out part B says find the actual speed. Okay, so what I need to do is figure out what y is now. Okay, so to solve for y, I have 400 sine theta plus 55 sine 260, and I know that that's what y is going to equal because of this equation right here. And I know what the direction angle is. It's this 271.37. So that's what I'm putting in for that theta value right there. So I'm doing 400 sine 271.37 plus 55 sine 260, and that's going to give me that y equals negative 454.05. So at this point I can write what the actual vector is. So this is what is going to make sure that we're going south here. And if I want to find what the actual speed is, I just need to do the magnitude of this. Now, when one of them's 0, it's just the absolute value of the other one. So we don't really need to do a whole lot of work here. And that is the answer. And now to preemptively answer some questions, hopefully, that theta has to be this one, because when we do these formulas, magnitude cosine theta, magnitude sine theta, it's the direction angle that theta is. Not the reference angle, not the bearing angle. It's got to be the direction angle. Okay? And if you're still confused on that, I will erase all this stuff and I will do a comparison between the two real quick, and then I'm going to stop this lovely recording. I'm sure my neighbors think I'm talking to myself now. So, direction angles versus bearing angles. So direction angles start from here, Okay, so they start in the positive x-axis and they're going counterclockwise. Bearings are starting here, going clockwise, so north and clockwise. And when we find the reference angle, which is what we're doing when we do tan inverse most of the time, okay, reference angles are always between 0 and 90. So if I'm in this quadrant, okay, remember we're starting from here, this is where theta would be. So what I actually need to do is 90 minus theta, because I want to go down to here and then subtract the theta value. If I'm here, okay, I need to go 90 plus the theta value. So this would be 90 plus theta, because again, that's where theta would be chilling as a reference angle. If I'm way over here, okay, this time I need to go 90, 180, 270 minus that theta value. And if I'm up here, it's going to be 90, 180, 270 plus theta. So this is 270 plus theta. And that should be logical. You should not need to memorize this. I know some of you are frantically writing it down right now to memorize it, but you don't need to. It's logical. If this is where theta is and we start here, we're just counting 90 and we're either going backwards by theta, so subtracting theta, or we're going forwards by theta, adding theta. Come all the way over here, 270, we're either going backwards or forwards, either adding or subtracting. Direction angles are the exact same thing. If we are in quadrant 1, then we are in luck. It is just that reference angle. If we are in quadrant 2, we need to go to 180 and subtract the reference angle. If we're in quadrant 3, we need to go 180 and add the reference angle. If we're in quadrant 4, we have two options here. We can either go to 360 and then subtract the reference angle, or we could just do negative theta. So the reference angle is used to find both of these things, but it all depends on where we're starting. Okay, super important that we remember that bearings are always starting here, going this way, and that direction angles are always starting here and going that way. Woo! So much fun, isn't it?